Okay, welcome to today's lesson. We're going to look at something called critical points and critical values here. And critical points and critical values, for our purposes anyway, they are going to be maximum and minimum points. There's other points as well that are classified as criticals, but that's what we're going to be looking at mostly. And of course, if you think about a maximum value, such as a parabola or a minimum value on a curve, if you look at the tangent line at those points, the tangents are actually horizontal. And horizontal lines, of course, have a slope of 0. So how do we locate maximums and minimums? Well, we find the derivative of the function and we set it equal to 0. We solve that equation, and that will tell us the x values of the maximums or minimum values. And that's what we classify as the critical values. So we calculate the derivative, we find the values of x where the derivative is equal to 0 or undefined, but we won't be seeing any of those in this course. So those x values are what we call the critical values. Now, sometimes they want you to plug those critical values back into the original function to find the y-coordinates of the critical points. Especially if you're drawing the graph, you're going to need the critical points and not just the critical values. So here's an example here now. Well, let's have a look at this one. This example says, identify the critical points. So you know, because they're asking for points, you're going to have to give your solutions like points, the x and the y values. And here's your function right there. It's a cubic function, which usually looks like a sideways S shape. So step number 1, let's calculate the derivative of this cubic function. And what you're going to get is 3x squared and subtract 6x. So that's your derivative. We set the derivative equal to 0. And in other words, you're solving 3x squared minus 6x is equal to 0. Now that's quadratic. So you're going to get two solutions, but the easiest way to solve this, of course, you can see there's a common factor. So you take your 3x in front, and you will have left in your brackets x minus 2 equals 0. So you had two pieces here multiplied together. Here you have 3x. Well, if 3x is equal to 0, you divide both sides here by 3, and you get x equals 0. So that's one of your critical values. When x is equal to 0, there's either a maximum or a minimum. You're not sure which yet, but it's one of them. Now, or this piece could equal 0, which would give you x equals 2. So there's your two critical values. That's where the maximums and or minimums occur. Now, because they're asking for the points, of course, what you need to do is take those two values and you plug them into the original function to get your y values as well. So, step number 1, let me just move that out of the way. F of 0, you plug 0 into the original function, and of course you'll get 0 cubed minus 3 times 0 squared. So that is 0. So that tells you that 0, 0 is one of your critical points. It's either a maximum value or a minimum on the top or the bottom of a curve. You're not sure which yet, but it's one of them. And then you plug the 2, the other critical value, into your function. And what you will get there is 8 subtract 12, which I'm pretty sure is negative 4. So the other critical value that you're going to get is 2, negative 4. Now, of course, if you were graphing that function, these 2 points would be absolutely vital to plot correctly and to plot accurately and to work out. So the next part on that page, on page 8, basically gives us a little test that we can use to determine if they're maximums or if they're minimums. What can we do to determine what they are? Well, if you look at the graph, look at the function on the sides of 0 and 2. So you look to the left of 0, you look in between 0 and 2, and you look to the right of 2. You can tell if the graph is increasing or if the graph is decreasing. Well, when is the graph or when is the function increasing? The function is increasing when the first derivative is greater than 0, because remember, the derivative is your slope. And if you have a curve like so that's going upwards, then your derivative is going to be positive. It's sloping upwards. But the graph will be decreasing or going down if the derivative is less than 0. So, for example, here's a piece of a curve that's sloping downward. Well, just look at that. Look at the tangent line to that curve. It's got a negative slope. So the derivative would be negative. The derivative would be less than 0. And that's what this little test here is telling you. This is telling you that you can make a table. And we'll do a table now in just a moment. But into that table you put your critical values and you test to the left and to the right of all your critical values and in between the critical values as well. And you find out where's the function increasing and where's the function decreasing. But like I say, we'll do that now in just a moment. Before we do that, though, on the next page, there's a very simple example. This is page 9. Now, all they're doing here is they're asking you to look at this curve, and you can see they've placed various points on the curve, A, B, C. There's D down below, and there's a point E. Well, can you fill in these blanks here now? Can you tell what these things are? So, for example, at point B, now there's point B right there. It's kind of on the top of a curve. It is a maximum value, but it's not what we call an absolute maximum. That's not the greatest value that the function takes on, because you can see over here that there's places where the y value or where the function has a greater value than at B. So it's not an absolute maximum, but if you were only looking at the region around that point, it is what we call a relative maximum. So that's what we have, relative. I'll just put max there for now, but if you have the space there, write the word maximum. Now D you can see right here, and it's kind of like the opposite of B. It's at the bottom of a curve. But again, it's not the absolute minimum value for that function, because over here you can see other y values that are actually lower. But it is, for that little area, for that little piece, it is the minimum. So we call this a relative minimum. Okay, what about from A to B? What is the graph doing from A to B? Well, from A all the way up to B, it's getting higher and higher and higher. And if you were to look at the derivative, look at the slope of the tangent line, it's positive. So from A to B, the graph is increasing. It's getting bigger. From B to D, if we go back up and look, well, there's B right at the very top. And all the way down to D, the graph is decreasing. And of course, the derivative there, this pen is still not working well. The derivative there, of course, would be negative. From D to E, well, if you look at that, the graph is increasing again. But B and D, they're what we call the critical values. Actually, they're the critical points. So from D to E, the graph is increasing once again. Okay, what else does it say? What about at point A? Well, there you go. If the graph is increasing, that slope, ladies and gentlemen, is positive. And like I say, this is a little test that we can do to determine if there are maximums or minimums. At B, there's your max. Well, if you were to draw a tangent line there, the slope is 0. At C, okay, look at that. It's going downward. The slope is negative. And at point D, which is right at the very bottom again, it's a relative minimum. The slope is 0 once more. And at E, right there, you can see the graph is increasing again. The slope would be positive. And that region right there. So I think we have time on this video to do one example on the next page. And I'm probably going to do a second video for today. So I'll do example 2 on the remainder of this video, and then I'll do example 3 on another video. We'll call it part A and part B. And I'll probably get around to doing example 4 in class tomorrow. So let's look at example A, example number 2, sorry. Part A says identify the critical values. Now where they say values, that means the X only. If they had said critical points, you would have had to locate the X and the Y. So what we do is we find a derivative of x, and that's equal to All right, what do we have? We have 3x squared, and the derivative of 2x squared would be plus 4x, and the derivative of plus x is plus 1, and then plus 1. So you set this equal to 0, and you solve 3x squared plus 4x plus 1 is equal to 0. Now, the question becomes, how are you going to solve that? If it factor, wonderful. If it doesn't factor, you'd have to use your quadratic formula, because I'm in a little bit of a rush here. I want to let you know that yes, it does factor into 3x plus 1 and also x plus 1. So now if you solve each piece, you could have 3x plus 1 equals 0. And you bring your 1 over, it becomes negative 1 divided by 3. So here is 1. Well, here the critical values, it's negative 1/3. And of course, if x plus 1 is equal to 0, then that tells you that x is equal to negative 1. So there's your two critical values. Now, part B is where we're going to determine if they're maximums or minimums. All right? So what we do is we make a table. If you have two critical values, you're going to need a table that's got 5 columns. 1, 2, 3, 4, 5. Okay, a little bit off there, but that will do. And you're always going to have 3 rows. So watch carefully what we do. The column at the very end right there, leave that one blank for now. Leave the one in the middle blank and leave the one over on that end blank. But in the other two, column 2 and 4, you place those two x values, those two critical values. Now put the smaller one in the left-hand column. Well, negative 1 is smaller than negative 1/3. Now remember, those are your x values. Whoops, I shouldn't have put that x there. Let me just erase that because we need to put a number there. Okay, now here's what we do in those other columns. Find a number, think of any number that's a little bit less than negative 1, like negative 2. And over here to the far right column, think of a number that's a bit bigger than negative 1/3. So we'll just pick, well, even 0 would be okay. And now a number between negative 1 and negative 1/3, well, maybe negative 1/2. Okay? Now here in the second column, you actually work out the first derivative. You want the slope at all those points. Now you know the slope at the critical values are going to be 0. That's not going to change. And if you calculate the slopes at the other points, let me see. If you were to find the slope at negative 2, it actually becomes equal to 5. Now that's a positive slope. So in the very bottom column, just draw a little line like that, going upward, because that's positive. The critical values, the slope is horizontal. And this one is horizontal. And if you calculate the slope of negative 1/2, I've got these done beforehand, so I'll just tell you what they are. It's negative 1/4, so that's a negative slope. So draw a line going down. That's not a negative slope. And finally, if you find this, put 0 into your derivative, you're going to get back a 1, which is a positive slope again. Now look at those arrows on the very bottom. That tells you where it's increasing and where it's decreasing. In fact, you can see that right here, your graph is going to kind of go up, flatten out, and then go back down again. So this is a maximum. Over right here, your graph comes down, flattens out, and starts to go back up again. So there's your min. That's your minimum value. And where is the graph increasing and where is the graph decreasing? Well, let me just rub this out again here so I can give myself a little bit of space. I've got less than a minute left. Okay, it is increasing. And now you get these by looking at your table. Where is that function increasing? Well, it's increasing when x is less than negative 1. And if this one here was going up as well, x is greater than negative 1/3. And where is it decreasing? I've got about 15 seconds left. It's decreasing in between those values. So negative 1 less than x less than negative 1/3. That's where it's decreasing. Okay, I'll give you another example in video number 2.